Here for session 1. I've put the link in the chat for the second session. So we'll be getting into the scripting side of things during this session as well. We're going to finish up from session 1. So if you're brand new, go ahead and follow those links, get Binder up and running. If you were here with us before, then we're going to pick up right where we left off, which is in the dictionary. So I'm going to go ahead. Mary, the screen sharing has been disabled for me, probably because I'm no longer a co-host when I gave you the permissions.
There you go.
All right, perfect. Thank you. And let's get the chat up, get the participant. All right. So we'll go ahead and jump right in, and if people come in a little late and aren't sure where we're at, just if one of the helpers could just repaste that HackMD link in there and get everybody up and running. And otherwise, we'll go ahead and get started. Hope everybody had a good lunch break. We came back for another 2 hours of Python, so we haven't scared you off completely yet. And we're going to pick up with dictionaries. So before we get started, does anybody have any remaining questions from this morning? All right. Well, so we'll jump right into dictionaries then. And so this is the last data structure we're going to look at today. And so dictionaries are things exactly like what they sound like. There's a key and there's a value. So the word in our dictionary that we look up is the key, and then when we find that key, we can find out what the value of that key is, the definition of that word. So they always go inside of pairs. So if you're looking at the screen here, you'll notice that I have a dictionary of definitions. Again, we're using curly brackets. Okay. And each one is separated by a comma. So we have 2 keys and 2 values here. And the key and the value are separated by a colon. So this is some of the important punctuation that we'll need to be able to see and create dictionaries that we want to use. So before the colon, and the first item of the dictionary is aardvark. That is the key, and its value is the aardvark is a medium-sized burrowing nocturnal mammal native to Africa. So that's the end of item number 1. So we have a second item in our dictionary called boat. So before the colon is the key, and after the colon is the value. Okay, so we have a boat. A boat is a thing that floats on water. And again, this is going to be an item in the dictionary, and these will be key terms that come up when we want to get keys, or we want to get values, or we want to get items. So the key and the value pair out of the dictionary. So the first thing we need to do is actually go ahead and create this dictionary. So we're going to execute this cell, and it should run. It's being kind of slow. It doesn't look like I have a kernel. So I'm going to try and restart my kernel. All right. And does not look like it worked.
I had to go all the way back to Binder and relaunch.
So I'm going to leave and try and start it up this way. Oops, nope. All right, so we're going to have to go all the way back. So I'm going to copy this link. Go to mybinder.org. Paste this in. Launch. Should be much faster this time if you guys are having to follow along here. All right, I'm gonna open this up. Yeah, we haven't even gotten started. So while mine is loading there, a dictionary, think of it like a dictionary. So each one has a key and a value, each item. And so before the colon is going to be is the key. After the colon is going to be the value, and those go together. So the key tells us what the value is, and we can search in the key. So we'll be using keys, values, and items to extract different things out of the dictionary. So whether we want only the keys, or we want only the values, or we want to see the pairs of key and values, we'll use a different method. So I'm going to go ahead and load my space from where we left off. I'm going to wait. All right. Back down to dictionaries. And now we're back here. So let's go ahead and we'll try and create this dictionary one last time. All right, now I've got my one, I'm up and working. And we'll continue on. So now that we have a dictionary created, we can get information out of it and we can look it up by keys. So this next statement is going to print out the definition of aardvark, and we're going to look up that definition by its key value. So aardvark is before the colon, which makes it a key. And we're going to put that inside of our index square brackets here. And that's what's going to tell Python to go find this definition and print out its value. So when we print this, we have a nice formatted string that comes out. Basically just tells us the definition of aardvark is, okay, this is the first part, and then we get the definition or the value that is associated with the key aardvark in our dictionary. All right, so right off the bat, how would you print out the key or the definition for boat? All right, and if you have successfully gotten this done, go ahead and give me a thumbs up so I know when we can trek along a little bit. Okay, I see people starting to get there. All right, very good. So what we would do is give it the print command, and we're going to grab the dictionary. This is where tab completion comes in really handy. And we're going to give it the square brackets so that it knows what we're going to give it. We're going to give it the key, and we're going to say, I want boat. And here is our definition of a boat. Okay, so just like lists and sets that we saw earlier, we can, dictionaries are mutable, which means that we can add to or remove things from. So we can change them. So a dictionary definitions, all right, we want to add a new key, all right, so we give it the object, we give it the key in quotation marks, and we set what is that equal to, okay, and then this is our value. So we're assigning the definition of ocean to the key ocean that we're going to add to our dictionary. And this does go off the screen, just in case you guys are curious what's happening there. And then we're going to print it out again, and you'll see that ocean has now been added to our dictionary. So the length of our dictionary has gone from 2 items to 3 items. All right, and with that, we're going to try and practice creating one. So we're going to get a little bit of muscle memory here, start typing some things. So problem number 9 says that we're going to create a dictionary called zoo with at least 3 animal types with a different count for each animal. So the count is how many animals of that type are found in the zoo. So we have an animal type such as bear, and maybe there are 5 bears in our zoo. So we're going to create a dictionary that contains 3 of them, at least 3 animals. And I'll give you guys a few minutes to do that. And then once you're done, if somebody would paste their code in the chat window that they used, that would be great. And we'll use that as the example for the class.
There is a question in the chat that says, what is the purpose of some data structures being immutable?
To be immutable, it's a processing speed thing with the tuples. So it basically assigns it a place and it never moves. And so if you're looking for item 9099 in a tuple, it can get there much faster because it knows where that address is. If you're looking for item 9099 in a list, it literally starts and it checks item 0. Is that the thing that I want? No. Item 1, is that the thing that I want? No. And it does that 9098 times before it finds the place, the value that you're actually trying to get at. So it's in terms of processing speed, it's basically storing and making it available quicker and easier for later use. And Chun makes a good point too. If it's immutable, you'll get an error if you try to change it. So you can't accidentally change that in your code without completely overriding that variable. As we saw when we tried to use append or add to a tuple, it gave us an error and said that this method doesn't exist for this object type. All right, so I have somebody that put a volunteered their code in the chat. So I'm gonna do a quick copy and paste. All right, and so they've created a variable called zoo. It is a dictionary, and we know that by the curly braces. Items are marked off by commas, and the colon is marking the relationship between the key and the value. So we have animals as the key and we have counts as the value. So they put in tigers, penguins, coyotes, and orcas. All right, and then the second step was to print out the second item, the second animal in the dictionary. And so they have used the key to do that. And what we get is the value of 2. There are 2 penguins in this particular zoo. And we have created a dictionary that simple. All right. So any questions about dictionaries? That was our last big data structure before we move on to statements, which is going to add some logic so that we can start organizing these things into something that is comprehensible and make them do things for us other than, great, Drake, we made all this data and we looked at it. So now we're going to move into the part where we get the logic and we're combining these ideas that we've been talking about all morning into something that will present or produce something different for us. All right, none of my code. I tried restarting the kernel. What's wrong? So we actually had to go all the way out. We had to close it down and restart with the link and binder. You may need to do that. It didn't work for me restarting the kernel, probably because we left for an hour and never restarted it. And it basically killed it and served, to give the server space back that we were no longer using. So try a restart by pasting the link from GitHub back into the binder and see if that gets you back on track. And then that should get you there. If not, one of our helpers will get you taken care of. All right, so we're moving into statements. So this is where we can start processing data or doing data wrangling, manipulation. We can parse files, we can do data analysis in Python. So we have 2 main types of statements that we can use in Python: conditionals, okay, and loops. So loops are saying, if this thing is this, then do something. If it's not, do something different. A while, so while something is true, do this. And we're going to be looking at this right here. And if else statements are probably one of the most common. They're probably the easiest to wrap our minds around. They make sense when we think about them logically. So if we look at an if statement, it starts with if, and then we have some condition. So this has to be testable. But I just copy the link from you don't have to fork it again. So from your repository, you're just going to hit copy the link, the HTTPS, which I think is step 4. And then you would paste that link into the binder. So if this condition has to be testable, it has to be true or false. So, and then our syntax is a colon to end the line. This is just punctuation that tells Python that this is the end of my if line. And then I'm going to go down to the next line. I'm going to indent 4 spaces or a tab. Okay, Jupyter Notebook is going to do this indentation automatically for us. And if you're working on other things, you have to be careful about what that's doing. You may have to make some changes to the editor that you're using. And on this indented line, we're going to give it a command, do something. If this, so this is true, okay, now do this thing. All right, and then we're going to end with an else statement. So if this thing is false, we're not going to do the indentation line. We're going to go to the next line and say it's false. Then we're going to have do something different. So we're going to use comparison operators to say to show equality, not equal to, greater than, less than, greater than or equal to, less than or equal to. These are some things that we can do to compare. So let's look at the syntax in an actual code block so this makes sense to us. So we have a variable that we've given a value of 3.56. So what type of variable is this? What type of data is contained in this variable? Okay, good. Yeah, float, right? So it's a decimal. Our integers are only whole numbers. And so we're going to test logically. So we say if the value of the variable weight is greater than or equal to 2, all right? And then we use this colon to end the line. We go to the next line, we tab over, we have an indent, and it says, okay, if this is true, then I want you to print weight is greater than or equal to 2. Okay. So let's run this. And we'll see that 3.56 is greater than or equal to 2. Right. So this expression was evaluated and it says, yes, 3.56 is greater than 2. All right. But so now I'm going to do this thing. And everything else is skipped. None of it is processed. So how do we get to this else state? All right, so if we change the weight to 1.5, okay, when we run the expression now, it's going to say, okay, if 1.5 is greater than or equal to 2, do this thing. Well, it says, hey, this is false. So I'm going to go to the next thing. All right, so this is what I do when it's not greater than or equal to 2. So I'm going to print weight is less than 2. And now that we've updated our variable, we should get into the else statement. So it never looked at anything in this because it said this is false, go to the next thing. All right, so this is one comparison that we can do. So we can do equal to, our messages would change, but so if it was equal to 2, do this. If it's not, say it's less than 2. All right, we can see that each time we do that, it's going to keep printing out the thing. So 1.5. So, and if we change it to 2, we should get that top block now, and that 2 is greater than or equal to 2. So it ran this line of code and not this one. So this is one type of expression or comparison that we can do. The other thing is that we can say, okay, membership operators. So is this data present? So we've made all these lists and dictionaries and stuff. We can look to see if this item is in one of these types of data structures or not. It's going to evaluate true or false again. So here we have a grocery list, right? How do we know it's a list? Because it's inside of square brackets. All right, and so we have 4 items in our list, and we're going to see if we need to buy basil. So we're going to look to see, is basil in my list of groceries? And we're using this in operator. Okay, and then we get the same ending of line punctuation with the colon. And so it says, okay, go through this list of items, is basil here? And this is going to evaluate as false. So it's going to skip this line of code and say, okay, what do I do if basil is not in my list? And it says, okay, print do not need basil. All right, and we'll see that that outcome is what we get when we run this block of code. And what would happen if we changed it to tomato? Okay, it's going to go in, it's going to say, all right, bread is not tomato, but tomato is tomato. So it is in this. I need to buy tomato for my recipe. And well, I have to update the output as well, but so we'll buy tomato. And we can see that it's basically looking for true or false and making a decision based off of the outcome of that logical test. All right, so if we look at this block of code right now, using what we've just covered, what is going to be the outcome? What's going to be printed? Okay, have a good day. Have a nice day. Yep. All right. So this is saying if this thing is true. So notice we don't have, we have a different type of comparison here. We're not doing greater than or equal to, okay. We're gonna run that and you guys are right in the chat there. Have a nice day. So it says, if this is true, right, because that's what if is looking for. It says, if this is true, then I want you to do this thing. If it's false, go to the next thing. Okay, so because this is true, it prints out this first line of code. So what happens if we change it to false? We change this variable and we set it equal to false. What will it print now? Okay, yeah, have a nice night. And we see that that has happened. All right, so we have multiple ways to look at this and see if this is happening the way that we expect it to happen. All right, so we often compare between two values, but sometimes we want to use more than two. And so what happens when we don't find it, right? So we have username bin, all right? And so it says if username is equal to Marnie, we are going to print Marnie likes to program in Python, right? If it's false, we're going to go to the else statement and we're going to say, hey, we don't know who you are, all right? And right now, this is not very helpful to us, right? We don't know anybody except for Marnie. The only value that we're going to get is when Marnie is the username. So Python allows us to add in intermediate statements where we can say, test this first. Is the name Marnie there? Nope, Marnie is not there. So we're going to go to the next one. We're going to ask a different. So else if, so and this is abbreviated in the code as ELIF. So it says, okay, the username is Ben. Okay, if username is equal to Marnie, okay, that's Ben does not equal Marnie, that's false. Go to the next thing. All right. Else if the username is equal to Ben. Hey, my username is Ben. Okay, so print this thing out. Ben likes maps. Okay, and that's what we will see from the output. Here, Ben likes maps. So what happens if we change our username to Brian? We would go one step further. We would say Brian is not equal to Ben. So skip that. All right. Brian is equal to Brian. All right, print this one. So we would have to change our username and set it equal to Brian, not brain, Brian. All right, and we rerun this. And now it says Brian likes plant genomes. But if we said username is Blake, we go through and it says, hey, we don't have a record. We don't know who you are yet. We don't know what you like. So it goes down and it tests them in logical order from the top to the bottom. Okay, and then there's something else that we need to pay attention to, which is the equal sign. So when we assign a variable something, we use one equal sign. when we want to compare, do a comparison, we use 2 equal signs. So we want to know, is this username, the value, the same as this value? Okay, and we go down the list until we find one, or we say, there's no person named Blake in this set of data that I have to look at, and so we don't know who you are. All right. So let's take a look at this problem here. So take a look at this code. All right, and see if you can tell me what it's going to print before we do it. Yes, not equals to as an exclamation point followed by an equal sign. So this code here, it's written in Markdown, so it's not executable. All right, what is it going to print? Okay, I see one person saying it equals 25. All right, would either of you like to unmute and explain why that is the correct thing?
Because it reads from top to bottom.
Okay,
And
it reads from top to bottom, good.
and that one is before the less than or equal to 30.
Okay, good. So we have my num is equal to 8 plus the value of my num, which is 42. Okay, so that gets to 50. And new num is equal to my num divided by 2. Okay, so the new number is equal to 25. So if we look at this, we test. If new number is greater than or equal to the 30, it'll print greater than 30. Else if my num is equal to 25, print out equals 25. All right, and then else if new num is less than or equal to 30, print out less than 30. And if none of those match, we're going to get print unknown. So what we're going to do is we're going to test this. We're going to copy this. And we're going to put a new cell below. And we're going to run it as Python code and see what we get. So it says less than 30. So this seems like a mistake. Right? It equals 25. So why is it not telling us that it equals 25?
Yeah, I want to guess and say it's because that one came out lower in the script. It presents after the equals 25, so it reports that instead. But I don't know. I was wondering the same thing.
Okay, that's a really good guess, right? So something didn't work. Yeah, so the helpers are putting in some hints for you guys in the chat. Look at the variable names. What are we testing in the first else if statement? We're not looking at the value of new num. That one's testing the value of my num. So my num is equal to 50. It's not equal to 25, right? So this is a common mistake though. And this is why when we're looking at things and we're programming, we're gonna make these types of mistakes. And we're like, hey, this answer should be 25. And this is why it's really good to make sure that we're checking those assumptions, because we've actually made an error in our variable name. And if we correct that, then we will get our expected outcome. Okay, so this is just a simple idea of how mistakes can happen, just very quickly. We don't think about it, and then if we don't test these assumptions, then we go and we're like, oh my gosh, where did it go wrong? And so I don't know how many people got to attend the keynote or the panel discussion this morning, but this is one of the things, and this is the importance of working on one thing at a time and testing those assumptions before you move on. Because it's easy to fix this problem when we only have 8 or 10 lines of code. But if we had written this at the beginning of our program and 1,000 lines of code later, we don't get the expected output that we want, we don't know where to look to find that mistake. So when we do one thing at a time, that's where we want to be at, so that we can change things and find those errors easier. And we're going to save ourselves a lot of time and a lot of heartache as we're trying to make sure that we're getting our programs working the way that we want them to. All right. Let's see if we can write an if then, an if else statement for the dictionary that we created for zoo. So if your kernel is shut down, you may have to scroll back up and rerun your dictionary with the zoo in it from above. If you haven't been kicked out yet, you should be good to go. I'm going to run this one again just in case. I don't remember if I've gotten kicked out since then. And so we're going to run an if statement to get these, look at the length of the dictionary, see how many items we have in our dictionary and what we're going to do with that. So I'll give a few minutes, and then if somebody would like to paste the code that they used, we'll use that over again. All right. So we're going to start our if statement. So how do we check to see how many items are in our dictionary? What function are we going to be using? Okay, good, length. Okay, so f length of zoo. Okay, is greater than or equal to, or greater than equal to 3. All right, we're going to print a message that says there are 3 or more animals. Actually, it says there are 4 or more animals, because it says we want more than 3 animals, which means that we need to change our comparison operator to be greater than 3. Okay, and we'll fix the grammar there. And if it does not, we'll say else print there are 3 or less animals. All right, and if we run this, we should get, there are 4 more animals, because the dictionary that I had from the workshop was penguins, tigers, orcas, and something else. coyotes. So we had 4 animals. All right, and so if you wanted to add an else if statement to be equal to, okay, we could add that in. Now if the length of zoo is equal to 3 animals, exactly, print there are 3 animals in my zoo. All right, my answer is not, my output's not going to change because I have 4 animals. But if you happen, your dictionary had 3, adding this line should change your output to there are 3 animals, not more, not less. All right. Any questions here on if and then statements? No? All right, then we'll get into loops, which can start to be very helpful for us doing the same thing over and over and over again. All right, so a loop tells the program to do it over and over and over again. So a loop executes the same exact command for each value in some collection. So we have a list and we want to do the same thing for every item in the list. We're going to want to use a for loop so that it goes through each item iteratively and does the same command to each item in that list. So this is what the syntax is going to look like. So instead of starting with if, we're going to start with for, and then we're going to have each item. And then we have whatever variable that we're going to search through. So a list, a tuple, dictionary, etc. And then we end that line with that colon to tell it, hey, this is the end of the line. We indent over, and this is the command that we give it. So let's take a look. So this code here, I want everybody to run this and prove to themselves that we get a name error, which means that number does not exist yet. Give me a thumbs up if you got an error here. All right. Very good. I see lots of thumbs ups coming. So the name error, it tells us that, hey, name, okay, number is not defined. I don't know what number means. You haven't given me a value for number yet. Okay, and this is important in understanding the structure of the for loop, because we're going to use number as our variable. So this can be anything. You could name this for orangutan in 10, range 10, and it would work. Okay, so long as what you're printing is the variable that you're using. So everybody agrees that number doesn't know what it is yet, but we're going to do something 10 times. Okay, and so for each number in this range of 10, I'm going to print the number. Okay, so this is going to start at what number, because we're using Python? What number does it start counting at? 0. Yeah, good. So when we hit print, or we run this, so we get this output 0 through 9. So this ran the same code 10 separate times. On the first run, number, the value of number was 0. And so when we print number, the number is 0. Okay, the second one is 1. Okay, and then we print 1. Then we go 2. All right, and then once we've done it 10 times, it says, okay, I've done it all the times that you asked me to do it. So I'm done. I'm going to move on to the next step now. But it won't go past this until it's run 10 times. Now you can do this. You can put any number that you want in here. We could put 100 and run it. Take a little longer to run, but it's doing the same thing. So this is going to go from 0 to 99. Right, so sometimes we have a set number of items that we want to run through. Sometimes we have a range of items that we want to run through. Okay, and sometimes we want to just run through the end. So we can use a different type of loop for that, and we'll see that in just a minute. But let's take a look at the range. So we have range from 0 to 10. Okay, this is going to run 10 iterations. So we're going to get the exact same output that we got, 0 through 9. Runs it from 0 to 10. But I'm getting ready to set this up, and I'm going to switch it over to R. I'm going to take the stuff that I'm piping out of here into R later. And R starts at 1. So 0 is not very useful for R. So we can do the same thing, but get that data ready for R by changing our range from 1 to 11. We get the same 10 steps done, but our output is now starting, it's counting at 1, which could be very useful for our data set that we're going to use in R, which understands counting from 1 up instead of from 0 up like Python does. So we can use the range to determine what we want to do. All right. And then we can also do a couple of other things. What is happening here in this next one? We've added a third number in our list, -1. What do you think it's going to print here? Okay, reverse order. All right, let's test that theory. All right, very good. So it starts at 10 and it goes to 0 and it's in reverse order. Now this didn't get us all the way down to 0, and we're gonna be Python snobs, and we're saying we're not gonna go to R. I need this to get down to 0. How would we change this code to make it go from 0 to 9 in reverse order? I'm going to cheat and copy this, and we'll modify it from there. So what would we have to change? What would be our range? All right. So if we change this down to 9, that'll start. The first value should be 9, so it was 10 here. We want 9 to 0. All right, very good. So if we run this one, we still go 9 to 1. And so to get down to 0, we're going to have to go to -1. All right, and so this is how we can manipulate the data and do things that we need to do. This is probably still seeming like, why in the world am I doing this? But here's where the rubber kind of meets the road. So somebody asked earlier, how do I get the links of all those strings in my list? This is where we would do it. So we would take a look at this. We would say, oh, we're gonna, for each of these strings, I want to get a value. And for that value, I want to add to my value that I already have. So here, we're going to start at 0. We've defined the variable total, and we said that's equal to 0. We're going to run this thing 10 times. All right, and what are we going to do? We're going to do 2 things. We're going to take the value of 0, and we're going to add it to whatever that value currently is, plus I, which is the number of iterations. So the first one is going to be 0 equals 0 plus 0. All right, and then print out that total, it's going to be 0. Then we're going to run that loop for the second time. And total is still going to be 0. So it's going to be 0 equals 0 plus 1 this time, because now I is equal to 1. And we're going to continue running that 10 times, and we're going to get all these numbers. So now the third iteration of this loop, total equals 1. So 1 plus 2 is equal to 3. Okay, when we print it out now. So now 3 equals 3 plus 3. And so we have 6. and we keep adding on each time that we go through. And it's printing out each iteration. Now, this is really useful. Sometimes it's really useful for what we're doing, but sometimes it's only useful for making sure that we're getting the expected outputs that we want. And in the end, we actually only want the last number. So what is the difference between this code block that's been run as item number 32 and this one down here, which is going to be run as number 33? We get the same code, but two different outputs. We only changed one thing. So what did we change? This one might be easier to unmute and speak up. Okay, whether or not you have print. All right, so good. So Python says, hey, all of this stuff, right, that indentation says, during this loop, I want you to do this thing. Okay, this, because it's not indented, is not part of the for loop. So the for loop runs through, it does all the calculations, and then it says, okay, I'm done with this loop. I ran it 10 times. I have my value for total. And then the next command that you give me is, I'm ready to go on, continue with the program. It says, oh, now you want me to tell you what the total is. Okay, so if we tab that over, notice it goes back. So now it says, for each loop, I want you to do the total and I want you to tell me what it is. Then go to the next iteration of the loop. Right? And that's all because of the indentation. So if we move this out of the indentation, Python says, oh, that's not part of the loop. That's something that I'm going to do after this loop is over. Okay, and we get 45, which is the same number that we got when we printed out each loop. And that's what we expect. Okay. All right, so we've got some loops. These things can save us time. Just like before, we said we could print apple, banana, and mango. All right, but what if we want to print all of those and there's 1,000 items in our list? We don't want to write 1,000 print statements to accomplish that. So we write one print statement. And we loop through all the items in the list that we have. So we write the list, apple, banana, mango, and then we go for each fruit, okay? In that list of fruit, print the fruit that we have. And so when we get this, we're gonna see the first 3 print statements. Then I added in a second print statement to show you that we've moved on past this and now we're going into the loop. And notice that our output is exactly the same. All right. Now, did I have to name this fruit to make it work? No, I see my helpers shaking their heads no, because our videos are on. No, right? We could call this anything. So we could call this X. And as long as we tell it to print X, it'll give us the same exact output. So this name is whatever you want to name it. So I named it fruit because it was easier to read. So if I sent this to somebody, somebody would be like, okay, I kind of understand what's going on here. So it's just an informative name and we get this stuff. All right. So this is a way to print. So we could print out the values of each of those string links that we had earlier. And this is where it gets fun. We can start to create our own data. So if I have a data set and I want to multiply it by some constant, I can do that. So here I have this data set created, and then I have data2 as a list, and it's empty. There's nothing in it right now, but it sets up the list so that I can put stuff in using that append method that we saw earlier. And so it says for I in data. So for every item that's in this data set, 35, 45, 60, 1.5, 40, and 50, we're going to append a value into data 2. That is whatever the value of I is multiplied by 2. And then at the end, we're going to print out our data. So for 35, when it gets there for item 1, the first time through, it's going to say, okay, I is equal to 35. 35 times 2 is 70. So I want you to append 70 as the first data point in data 2 list. Then it goes to the next item in data. That's 45. 45 times 2 is 90, and so on. So we start looping these things around, and now our second data set is exactly data in the same order, but it's with a multiplier of 2. Okay, any questions here? All right. So I is just a variable. It could be anything. So we could call this orange. So this is just a placeholder. It's just storing the information. And this is going to give us exactly the same thing. Okay, because orange is what we told it that it's going to store. And that's what we're going to multiply, whatever that value is, times 2. And then we're going to add that to our data 2 set list. Okay, good question. All right. All right, so how could we use a loop to reverse a word? So we have a string called waterfall, and we have a reversed string that's currently empty. So using this logic, how could we access this information and create waterfall spelled backwards using a loop? I'm going to give you guys a few minutes to see if you guys can piece it together. And if you come up with a code system that works, great. Post that in the chat for us. And if you get done early, see if you can take the extra credit by doing it in one line. All right. Can I get a thumbs up at least if you guys have gotten something working, or a thumbs down if it's not working? Okay, I'm going to guess the lack of expressions means that everybody's working very hard. Okay, I've got a couple of slowdowns and a couple of it's not working. All right, so let's go through this together. So remember that strings are indexed. Okay, we need another minute? Perfect. Why don't we go ahead and take a 5-minute break, and if you guys want to keep working on it, you can, but if you need a time to stretch, let's take a 5-minute break. We're about midway through the second session, and we'll come back at 5 after the hour and go over it. So let's go ahead and work on this together. So the first thing that we're going to want to do is access the information inside of the string. We want to know what the string is. Okay, so remember we have an index for each thing, so we can iterate through here. And so what we're going to do is say for, I'm going to use char as my variable name. Again, it doesn't matter. All right, and I'm going to say if it's in this variable. So if it's in string. All right, and then what am I going to do? For the first character, I'm going to grab W. All right, so reverse string is empty. So I'm going to say, this is what I want to build. Reverse string. I'm going to make it equal to itself. Okay, but I want it to go backwards, so I'm going to put this character first. So I'm going left to right, so if I reverse it, my reverse string should be right to left. So I'm going to put in my variable that I'm storing in each iteration of the loop. And so it's going to say character plus reverse string. So right now it's W plus nothing. The second time it's going to be A plus W. The third time is going to be T plus AW. And it's going to loop through each of these things and give us a printout of waterfall spelled backwards. All right, and if we wanted to see what was happening at each individual step, we could add a print statement in this loop to see each step. And we could watch it happen. So the first one was W, because there was nothing. And the second one was AW, because we got A and we added to what was already there, W. The second one was the third time through, we got T. So we added T to what was already there, AW. Then we got E, we added E to TAW, and so on until we got the whole word reversed all the way through at the bottom. And that is all there is to it. All right, so that is our reverse string. This one requires a Google search as to what's going on with it. But we can do this in a one-liner. We can say print string, and we want to print each item of the string, and we want to do it in reverse. So we use that -1 notation, and we see that we get the same exact output. All right, and so we can loop through dictionaries, we can loop through lists, we can loop through anything that has a collection. So in the interest of time, I'm going to leave these items out for now, but they are here and you do have solutions. So if you want to work on them later, this is another type using for loops again, but looping through a dictionary. All right. So the second type of loop that I told you that we had was a while loop. So while is testing for true or false, and it determines whether the loop continues or the loop says hey, this thing is false now, I'm not going to continue anymore. All right. So if we look at this, we have defined a variable called my_num, and we've set it equal to 10. And so it says, while my_num is greater than 0. Okay, I want you to print my number and then whatever the value is. After you've printed that, I want you to take the value of my_num and I want you to subtract 1 from it. So after the first loop, my_num goes from 10 to 9. Then 9 to 8. Then 8 to 7. 7 to 6, and so on. Until it says, hey, I'm no longer greater than 0. So it gets down to 0 and it says 0 is not greater than 0. So quit running. Go to the next step in the program now, which is this print statement, which is not indented, so it's not part of the while loop. Okay, so this print is getting printed every single time. This only gets printed once the loop is finished. Now, what's the danger with a loop? What would happen if I deleted this and hit run? Don't do this, anybody, but what would happen? My number is always going to have a number. It's always going to evaluate the true, and it's never ending, right? It's going to be a continuous loop, and it's just going to keep going on and on and on forever. And you're going to have to end it and close down the thing, and sometimes it will lock up your computer, right? And so you have to be really careful to make sure that you actually give it a qualifier that will eventually evaluate the false so that that loop ends and it doesn't go on forever. And that is the basics of Python and data structures, the types of variables that we have, the types of statements that we might write in normal everyday programs. So up to this point, all we have done is create data to play with and see. Okay, so what if we already have data that we want to look at? So we're going to use pandas as a way to look at some information. So it's a package that is a very good data wrangling package that's built for Python. So it's called pandas, but you'll often see it shortened up as PD. So when you're looking for things online, you'll often see things like PD, and that's because they've imported pandas and they've given it an abbreviation, a nickname. Okay, so we're going to import this one to give that shortened name so that everything else works below. Okay, so make sure you run this block. It's important. Nothing else will work as if this is not loaded. Okay, so we have people use different things on a daily basis. So many people use Excel. Some people use just CSV files or plain text files. Okay, so we have the ability to read both. And basically what this is going to show is that we have this open source data, and we're going to read in this file. So one is in an Excel format, okay, and one is in a CSV format. But where is this data coming from? So this first part is the path. Where do we find this thing? So we're in a folder called Gapminder data. So let's look at our folder structure here. So this is the area or the project that we're working in, right? And so we have Gapminder data. We see this is a folder. So if we open up this folder, we see that we have another folder containing some files. But we also have this raw CSV for Afghanistan, and we have a raw Excel file. Okay, so this is where we're getting this data from. So it's not like, you know, we have it all there for you already. And then if we open up this while we're here, we'll see that we have all of these files with this weird extension out on it, .cc, .txt, okay? And these are text files containing data about these countries. All right, so when we go back here, we see that we went from our current location into the Gapminder data folder, and then we found this file. We said, hey, we want to read this file. So if you've imported pandas correctly, you should not get an error here. And you should not get an error on the CSV file either. So if you get numbers here successfully, we are good to go. All right, so if I can get a thumbs up that everybody's followed me to this point. Okay, see a couple of people coming in with thumbs ups. Good. All right, perfect. So everything's working. We've got it all going. And so what we've done is we've used a relative path. Okay, so it says, hey, we're in this project location, and in this project location, you will find a folder called Gapminder Data. And inside of that folder, you're going to find this file. The reason this is important is because it makes this program movable, right? It doesn't include your computer name or any specialized things that is going to be different than anybody else's computer. And so if you send this to me, I could run your file. And because I've already bypassed all of that information that is specific to my computer, we can still find this data and the script will run. Okay, the alternative to that is an absolute path. And this includes your computer's name. So the example here is I'm at work and I've coded this as an absolute path instead of a relative path, which goes all the way to the very root, smallest area of my computer and says, okay, I want you to go to users, I want you to go to Drake Asberry, I want you to go to the desktop, I want you to go find this file, intro of Python. Then I email that script to myself and I go home and I'm working on my personal computer at home and my username is not Drake Asberry anymore, but it's Drake. This script won't work anymore because it doesn't understand that Drake Asberry and Drake are the same thing. So what the relative path does is it says, hey, I only want to use this part, desktop. So you have to start at desktop. And from desktop, you'll find this and this and this. And that is exactly the same in both. So that's the difference between a relative path and an absolute path. So in general, you're going to want to use relative paths for most things so that you can move it around and it will still run on somebody else's computer. All right, so now that we have imported these files, we can print them out on the screen. Okay, and so I've added in some text and some extra line breaks here just to make it a little easier to read. But you'll see that we have an Excel file, and we have all this text, and we have a CSV file, and we have the same text. So we've imported both the CSV and the Excel file. They both contain the same data, and they both display the same way. So it really is a personal preference as to what format that you work on with whoever you're working on, even if it's by yourself. I tend to use CSV files most of the time because an Excel file is proprietary, which means it costs money. You have to pay to use the program, and not everybody has access to that. So using an Excel file can limit people's access to that data. So I use a CSV file because you can open it up in pretty much anything, even a simple basic text editor that has no value associated to it that I have to pay out of my pocket in order to be able to use. So again, it is a preference, depends on who you're working with and what your goal is and whatnot. So that's the print, all right? And this still kind of looks like, well, okay, that's great. We can see some stuff. But Pandas does a really good job at making it a little more visually appealing. So by default, if we just give it the name, so if we give it the name, we can read this Excel table, the Excel file, and we can look at the CSV file. All right, and we have both things being displayed here. They're both working, they're what we expect. And we can start to now visualize the data that we have as opposed to just, I have this huge data set, I don't really know what's in it, how do I even get started, right? So this is a small data set that we have, it's only got 13 rows. But if you're looking at this data set, do you notice anything that just stands out about data? And this would be a good talking point, so you could unmute if you wanted to. We've got missing data. All right, and how many different ways is missing data shown here? We have to be determined. We have there's nothing here, so it's null, it's empty, the NaN. And then we have somebody in the population column wrote, do we need more data? Question mark. Right? This is typical of data. Data very rarely comes in clean and ready to use, right? So the first part of most things is that we have to get the data cleaned up and make some decisions about what we're going to be working with. So we have some tools that we can use. And generally we spend more time here, but there's a whole session on Wednesday about pandas and doing exactly this. So we're going to move through this section a little quicker than I would usually do it, just to take a look and see what's going on here. So to investigate our data, we can use unique. So let's say we want to look at the CSV file that we have. We want to look at the country column. Okay, the country column. And we want to get all the unique values that are in it. I want to know what they are. All right, so it says, hey, these are the two values that you have in the column called country. So you have Afghanistan and you have NaN, or a missing value. All right, that's great. So we have a whole row. Row 12 looks like somebody just hit enter and they didn't put anything in the entire row. There's no useful data here. Right? We have nothing there. So how do we get rid of it? We can drop the NAs. And this specification, how equals all, means I want to get rid of all the rows in my data set that have no value in any column. Okay, and so let's take a look and see what happens. So we run that, we get this nice table printout, and row 12 is now missing. Right? But if we print out the variable that we have it stored in, row 12 comes back. Why did row 12 come back? Yeah, we didn't say, hey, we want to replace this. So this type of workflow here is really good for doing a test, right? We didn't actually change our data, but we made a change and we previewed what that change would look like without actually making that change happen yet. And we say, hey, that did exactly what I wanted it to do. I needed to get rid of all my empty rows. Row 12 is missing, okay? And nothing else, everything else is still there. And then we can say, great, that's a change I want to make and I want to keep it. So we're going to say, take the value of the CSV data frame now. We're going to drop all the rows that have no information in them. And we're going to save it as the new file. We're going to make that change permanent now. And now when we do this, we'll get that. And now it's completely done. That row with no values in it will not come back into this CSV table output anymore. All right, so we still have something here. Row 13 doesn't really help us much. We know that everything should be Afghanistan. But we also don't have any data here. So we can also subset and work off of anything that has a country name in it. That's the only thing we want to keep. So country did not have a value for row 13. And this is, we're going to drop that null value for anything that doesn't have something in it. Now we have a clean, nice data set that's only Afghanistan. And we save that output into a different data frame. So now our data frame is called DF. Okay, and now if we check our assumptions, because this is what we've been learning about all day, is we need to check these assumptions, make sure that the computer actually has what we think it has. We're going to run unique again. All right, and now we can see that, hey, we only have one item in our list. So if this wasn't only 11 lines long, if it was 10,000 lines long, it would say, hey, Afghanistan's the only country you have here. And so this is a way to start looking at the data, taking a look and seeing what we have and what we're about to get into. Okay. And we're going to skip over the rest of pandas at this point, and we're going to jump down to the scripting part, because all of this stuff will be covered in Wednesday's session on the pandas package. So looking at all this stuff. So if this is something that's interesting or you find that might be useful, I highly encourage you to go attend that session on Wednesday. And we will jump down to some more basic fundamentals of programming, which was also a key topic, working on one thing at a time. So instead of building a program that does 1,000 things, we want to start thinking about it in little pieces. So building blocks. So each block does one thing, and we use that to call and use that information. And these things are called functions. So we've been using functions that Python has standard, but we can write our own functions. And this is where we can really start to build and start to reuse, and the time saving over different projects comes in over and over and over again. So you can write a Python function, save it, and you can use that in all of your other Python programs that would need that function, instead of copying and pasting all that code into a new program each time. You write it one time, and you can use it over and over as needed. So we have some syntax that we need to follow. So we want to define the function. So here we're going to use def to define this function. And the stuff that's in blue is the name. So again, this is any name that you want it to be, right? It needs to be informative, because if you write a whole bunch of functions and you don't give them an informative name, you'll never know which one what you need. And what you'll do is you'll wind up just rewriting the function instead of using what you've already written beforehand. Then we have parentheses. So parentheses is where we can pass parameters to the function. Okay, so they can have 0 parameters passed, like this one does. Or if we had a value that we wanted to pass to it, we would tell it what it is. And so the people that are familiar with R, these are the things that it works the same way. You pass the variables that you want to go into your function to work and then come back out. And as you can see, the consistency and the ending of that line punctuation for Python is that colon. So what is this going to do? When we hit execute on this cell, this is going to say, add 2 numbers together. So answer equals 50 plus 15. Return answer. All right, we executed it and we did absolutely nothing, right? But this code is run, okay? And it will run, and this is how we call the function. So we wrote this function a year ago, And now we're writing a new program today on a new research project that needs this function, and we can call it. So we bring this up and we say, hey, I've got this function that adds two numbers together. This is what I need. So in this program, I'm going to set the answer of that to x. I'm going to store it in a variable called x. All right. And then we're going to view what x is equal to. So 65. And in Jupyter Notebook, this is the same as print x. We can just use x and it will give us the same answer. But it did that, right? So all we did was say x equals add two numbers. And it said, okay, add two numbers. I know that function. It's up here, right? I already know what that is. That says add 15 and 50 together. And then I said, give me the answer. Tell me what it is. It's 65. All right. This seems really crazy and dumb because why in the world would I ever need a function that adds 50 and 15 over and over and over again? But what if 50 was your constant? And then for every number that you were working with, you needed to add this constant of change to. Well, now we can do that. So we're going to make a new function called add to constant. And this time we're going to give it something. We're going to give it num1. All right. And so this answer is 50 plus num1. So these two match. Whatever value we give this function, it's going to add 50 to it and return the answer. So here we have y. And we're going to say add to constant. What am I going to add to the constant? I'm going to add 10. So we would expect y to be equal to 60 in this case. All right, and I got an error. Why did I get an error? Anybody want to take a guess? Do some practice on the error message reading. So I look at my error, it says, hey, there's a name error. Add to constant is not defined. So if we look up here, I never ran this. So I haven't told Python yet in this project what add to constant is. So I need to run this so that it has it available to use. Now that I've run it, Python knows what this function does. It has a value for it. And now I can run this, and it will give us the answer that we expect. And before, I hadn't defined it yet as a new function that is available. So we have 60. And then you guys can change the number if you want to, just to see what it does. So if we add 150 to it, for example, right? Now we can start to see like, hey, I can ask for some information and I can send that off and get a number back to my constant. If I put this in a for loop and I've got 10,000 temperature data points and I want to convert it to something different, I can also do that. Okay. And all we did was write this thing one time, and we reran that code 10,000 times in a for loop. And we got all of the answers out. Whatever that value was in that row, it added to the constant and gave us a new value, and we could store that value and use it for later. All right. So there's all kinds of reasons to make use of functions, your own functions, which is it helps us test. Okay, we write the code one time. We don't copy and paste. We don't make errors. We don't make modifications here and there. It's reusable. We can use it in multiple projects. The same code that we wrote one time, we can use in multiple projects. It's cleaner and it's a little easier to follow. Okay, so let's revisit this string idea. Okay, we reverse this string. Okay, and so we've decided that we're going to make a computer program that's what it does. It takes a word and it puts it in reverse order, and we think it's the greatest thing in the world. So we're going to create a function so that we can reuse it over and over and over and over again. And it says, no matter what we give it, it's going to be stored in this variable called string. And we're going to run it. So here we see something new. We haven't seen this so far. So this 3 quotation marks and the text in red is a description. What does this function do? So if you write a function and you send it to somebody, and it looks like the ones that we had up here, they have to understand what this thing does. They have to understand all the code behind it. What is the outcome of this thing? By giving the information, we say, hey, this is going to take the text that you give it, and it's going to reverse it, put it in reverse order. So you could put a comment like this and say the same thing. I have somebody asking why not use the pound sign to reuse. But if okay, first we're going to have to run it. So we're going to define the function. And then above that, I'm going to say, I don't know what this is. So I'm going to use a question mark because this is a way to get help for something we don't know. And I'm going to say reverse text. And I'm going to execute this. And here is the information that's in that quotes in red. So whatever you write in between these series of 3 quotation marks is going to show up in the help menu as a description of what this function does. And if we were to do the same thing for our function up here, add to constant, I believe it was called. And run that, it says there is no docstring. I didn't tell you what it was. So the comment with the using the pound sign will help give like sections of code, but this is a way of telling us what does that whole function do? What's the purpose of this function? So I don't have to understand all that code in there, but I have a relative idea of what to expect as an outcome of this. It's a very good question. All right, so now that we've defined this thing, we can put in waterfall. And just like before, we got it. All right, so we gave a string directly because we said, hey, we need a string. You know, we're being informative about what we need to pass to this. It needs to be a string. All right, and then we could also go ahead and make it a variable. And so we could pass a variable to it. So here we've said original is storing the string pool. We're going to pass that variable original into our function called reverse text, and it will reverse that text. And so if we change that and we rerun it, it'll update with that variable, and we're only changing it in one place. So this would be a thing you would say, hey, give me a word, and the user would type in a word, and it would be stored in this variable called original, and then original would get sent to reverse text. It would run this code and give you back out the answer of whatever the user gave you in the reverse order of the spelling of the word. So that seems great and all, but somebody, not myself, a long time ago, could we also write this? So I have a question in the chat. So let's just test it. So let's paste this, and I believe this is what you are asking. All right, and we're gonna name this as, I'm gonna overwrite mine so that the rest of the code works. And we say this, so we got no error. And there we go. You're welcome. All right, so here somebody wrote a function that converts temperatures. So here we're going to not only give it one thing to work with, but we're going to give it two. So the first thing that we're going to give it is temperature. The second is going to be unit. All right, so this function says it converts temperatures from Fahrenheit to Celsius and vice versa. So you can give it a temperature and you tell it whether it's Fahrenheit or Celsius. If you tell it it's Fahrenheit, it'll give you the Celsius conversion. If you tell it Celsius, it'll give you the Fahrenheit. So we see this. We're going to go ahead and run it so that it's defined and we can use it. And then it says convert temperature. So later in our program, we say, hey, I have a temperature that's 85 degrees Celsius, and I need to know what that is in Fahrenheit. So we're going to run this, and it says 85 degrees Celsius is 185 degrees in Fahrenheit. All right, and then like we said with user input, we can do the same thing, but we can ask for the input. So here we're going to name a new function, and it's called convert temperature to. We're going to hit that. And notice now we're not passing any variables into this, but inside of this function, it's going to go and ask for user input. So if we run this, it says enter the temperature. Okay, so here's the text that we're getting. And so we can put in any temperature that we want. So I'm going to use 100 degrees. All right, and that's a unit in Celsius. Oh no, it doesn't work because I used a lowercase c. Okay, don't know how to convert. So it said, hey, is this a C? Nope, it's not, because a capital C and a lowercase c are different. All right, so it says, nope, that's false. So check and see if it's Fahrenheit. Okay, it's not F either. So the only thing that I can do is say, I don't know how to convert that. So if we do it and we follow the instructions correctly, 100 degrees, and we use Celsius with a capital C, now it will evaluate as true, and it tells us, hey, the user entered C for Celsius. Okay, so we need to convert that from Celsius to Fahrenheit. And we have the equation to do that, and it comes out and outputs 100 degrees Celsius is 212 degrees Fahrenheit. All right, that was a whirlwind of information. Do we have any questions? No. Okay. So what I would recommend doing is saving, and you guys can download. You can download this out as a notebook and save it to your computer. So if you've been taking notes, then you'll save this down and you can load this back up into your into a Jupyter notebook and open it up later for reference. Because once you close down your browser and it clears out all the cache, all the saving from browser and restoring from browser stuff will be removed, it'll be gone. So I would recommend saving it in some format. You could even do it in a PDF, however you feel, whatever you want to do there. There's a ton of options, but I would recommend doing one of those. And so there's another question in the chat about if there's this, why use the longer version? A return statement is actually not even necessary in all cases for a function. So there are sometimes that we only want to return certain aspects of that function where the other things are being calculated and are not being returned and we're not going to be accessible. So it's probably just convention, and that's what I've done my whole time. Somebody else may be able to answer that question better, Chun or Julian. All right, and so we've got about 15 minutes left. And what we're going to do is actually go ahead and once you guys have downloaded, you've saved a copy, we're going to open up a second notebook that is in here. And we can get to that one of two ways. You can go here to File and say Open. And that will open you back up to this page and you'll find that notebook. Or if you have this tab already open from before, you can just go back out and you can also click on that notebook to start it up. But we're going to start up the second Python notebook. And we're going to take a look and see what's in here and see if we can understand what's going on. You can leave it running if you want to. We're not going to go back to that other notebook and do anything in it anyways. So you're more than welcome to close that if you want. But just do a file open and open up the scripting practice one first. Yeah, okay. Thank you, Chun. All right, so here we have a new notebook and it's got that Gapminder data in it. And so we see some things that are familiar now. We see we have pandas as a package and we're going to import it as PD. We're going to give it a nickname, a shorter name. And then we're going to import another package, another Python package called glub. And this is going to allow us to use basically a search criteria to find certain things. And so we need both of these in order to make this stuff work. So we have a couple of functions here. We have 3 functions that have been defined. And then we have some code. And we have a for loop. And then we have some looking at my data and looking at what did we return. So this is kind of a very quick overview and a real world example of all the things kind of that we've looked at in the last 3.5 hours together. All right, so what could something like this look like? So this is a program that's basically going to come in. We have a couple of functions. So what does the first function do? All right, so we have doc strings telling us what to expect out of each of these functions. So it's going to go into a directory. So we have a search directory. All right, and it's going to search for a file type, a very specific file type, what we're going to tell it to look for. All right, and that is our search criteria. And basically what that does is it gets all of those files and it says, hey, get all these files, and then I want you to store all of these things in a file list that match this criteria. Okay, so that's the first thing. The second thing that we're going to do is read pandas. So we have a file, we have a delimiter, and we have some indexing, which I haven't talked about. Indexing will be covered in the pandas session on Wednesday. So again, I keep plugging that one, but you should definitely go. It'll be very informative, and pandas by itself could be a whole day long seminar. And then we have an add a header row. So this says, here's a file, it gets the columns and it calls df columns and that equals the header. All right, and we're going to return that out. And we have some things to look and see where we are. So this is present working directory. All right, so it tells us that we're in this weird internet site with Jovian as the user. Okay, if you're running this from your local machine, this would be probably represent what you have. And then ls is a way to list out all the files that we have in the current directory. So right now we're in this intro to Python. And so in intro to Python, we see that we have a folder, we have 2 notebooks, and we have 3 PNG files. And if we look at this output, we have a folder, we have 2 Python notebooks and 3 PNG files. So this is a way of looking to see what is in that directory without having to go open up another window and take a look and see what's in there. All right, so the first thing that we need to do is import our packages. So conventionally, this is done in the first thing. So we're going to run that one, and that's imported pandas and glob into our notebook. It's ready to use. The second thing we need to do is we need to make sure that our functions are all available for use. So we have to define them. So we're going to run these, and that's going to define these functions, although it's not doing anything for us just yet. All right, and we see that we have all these files, and now we actually get to the code where we're going to actually start doing something with this. So we're going to create a header file. So the header file is going to equal to read pandas. So we have read pandas. This is a function that we defined. All right, and it needs 3 things from us as the user to work. It needs a file, it needs a delimiter, and it needs indexing. So the first one, we give it the file. So is this a relative or an absolute path? Good, that's a relative, right? So it's not starting all the way from the very lowest point of our computer and working its way up. It's starting at the intro to Python project directory. Okay, and so it says, okay, great. So in that directory, you're going to find a folder called gapminder data. All right, and we see that here. So we're going to look at it. So there's gapminder data. All right, and so we click on that. And inside of that directory, you're going to find another folder called gapminder by country. All right, and so we come in here and we say, oh, there's another folder, gapminder by country. And we have all these files with this extension, .cc.txt. So here they all are. You know, we got a whole bunch of them. All right, and so we're going to find a specific file in that folder. All right, it's delimited by tabs, and indexing is going to be false. We don't want to have any indexing, which just means how pandas is going to treat the first column. All right, and so basically what we're going to do is we're going to look at that header row and we're going to rename it. We're going to rename one of our columns. It's listed as pop, and that's not quite informative enough, so we're going to rename it to be population. All right, and then we're going to have a header equal to this list, and we're going to hit run. All right, and nothing's happened yet. So now we have a header. It's available to us to use. We have a variable stored. Then we're going to go, we need to get all the files that we want to work with. So I'm going to just tell you right now that there's 142 files in there that have an extension of .cc.txt, okay, that are actual countries. There's 143 files because the header that we just created also has that same extension, .cc.txt. Okay, so we're going to get all of the files first using this collect files function. And it says, okay, for collect files, I need to know where to go look, and I need to know what criteria that I'm looking for. So we say, we need you to go look in this folder called gapminder data. And then I want you to look in the folder that you find there called gapminder by country. And I want you to find every file in there that ends in .cc.txt. This star is a wildcard. So this means it'll find Brazil.cc.txt, Guatemala.cc.txt. So it replaces any character. Okay, so this is our search criteria. We're gonna look for this extension. And then we know, because we know our data well, that this file doesn't actually have any country data, but it's just the header row, the information for the columns. So we're gonna remove that one from our list with that remove method. So let's go ahead and execute this block. Now we're gonna do something for each of these files. So we're gonna have I'm gonna print out the length here for us. So we have 142 files. That's what we expected, because you guys are gonna trust me on this one. Then we're gonna do something for these 142 files, the same thing for all of them. We're gonna get my data. We're gonna use the read pandas function. So what file are we gonna look at first? We're gonna look at this file. Okay, each file, remember this can be any name that we want it to be in the whole list of all of my files that I have. So we've given it the file, we've given it how it's separated, and whether or not we want to index. Okay. Then we're going to say my data dot columns is going to equal the header. So we're going to add a header row, give an informational point. So population, year, life expectancy, all these things. Then we're going to create a new name. So we're going to change the file extension. So right now the file extension is .cc.txt, which is 7 characters long. Then we're going to replace that with what we want it to be, a .csv file. And then we're going to save it as a CSV file with its new name. All right, so we're going to execute that. And we can look at the last one that was processed. All right, and now we should have a whole bunch of new files. So if we go over to our file, now we've just created 142 CSVs that have all of the information that we want. Country, year, population, they all have a header. They all have the information that they want. And we have created all of them with one for loop instead of doing that, opening that up, converting it, and saving it out each time, 142 times. All right, and so we can reuse that function if we wanted to see a list of those. We can look. Gapminder data. Invalid syntax. Not sure why I'm getting a syntax error there. Is that not the name of the folder? It's because I've moved my directory. So I'm going to go back out to intro Python, and then that should work. Gapminder data. So let's figure out where we are. Let's go with A, PWD. Intro to Python. Let's go LS, Gapminder data, Gapminder by country. I'm not sure why that's not working. We should be able to see the data there. We're not getting in there for some reason. It could be a binder issue here. But we should be able to get a list of, I'm not sure why that's not working up here. So we should be able to get a list of all of our CSV files using the collect files, and then we can double check to make sure we actually created the number of files that we thought, and it is 142. And this is just one way to show basically a quick little program of things that could be helpful for you doing this repetitive task using functions, for loops, the methods that we have seen today. And that brings us to the end of 4 hours of Python. So I'll open it up for any questions, and then the next session is starting in this room, I believe, right at 3 o'clock. And there is a feedback for the second half as well. I'm going to post that into the chat. And if you guys don't have any questions, have a great day and thanks for attending.
Hi, I have a question.
Yes.
In line 2, or that chunk of code 2, it says define collect files, search underscore their search underscore criteria. So does search there and search criteria, does Python already know what that is?
So we know that we need to expect these. So we have to give these. And if we don't give it to them, the function won't work. And so it gets this information from where we actually call the function in our program. So you have to look down, collect files. So we've given this is going to be read as search directory in this function because it goes in order. You have to keep it in the same order. Then the second thing that it needs is the search criteria. So inside of these parentheses, when we call the function collect files, we define what that is, which is why we can reuse this same function call and we can look up two different things. So here we went to the same folder, but we changed our search criteria.
Oh, got it. Okay.
Good
Thank
question.
you.
All right, guys, I'll let the helpers take that over and get everything set up and I will bug out. Thanks for attending, guys, and sticking with it for 4 whole hours.
All right, I'm gonna stop the recording